I'm on question number 5 today, right? Let's start from here. A container shaped like a right circular cylinder having diameter and height is full of ice cream. So there's a container in this form, in cylindrical form, whose diameter is given, that is 12 centimeter. Height is 15 centimeter. Okay, it is full of ice cream, right? So that means the quantity of ice cream is basically the volume of the cylinder. The ice cream is to be filled into cones of height 12 centimeter and diameter this. Okay, having a hemispherical shape on the top. So basically ice cream looks like this, isn't it? So there's a cone and then some is scooped out from here, right?
Yes, ma'am.
Okay, so if I just draw it a bigger to make it understandable, so it looks like this. So the height of each cone, that means cone is actually here. This height he is talking about. This is 12 centimeter, not the complete height. Understood, Hamna? Because the complete height is not cone. This much is cone and this much is actually your ice cream, isn't it?
Yes, ma'am.
He's talking about only cone. And diameter 6 centimeters. So this diameter is 6 centimeter. Having a hemispherical shape on top. Find the number of such cones which can be filled with ice cream. So in such kind of questions, number of cones will be basically, let's say total volume is 25, right? Just for an example, 25 centimeter cube. And you are filling it to cones, okay? And each cone is having a volume of, let's say, 5 centimeter cube. And you want to find how many cones are there. So ultimately, what will you do? You are going to divide the total volume by the volume of one cone, isn't it?
Yes, ma'am.
So that will give you what? This will give you number of cones. So same thing you will do here. You will find this volume first of all, and then the volume of each cone, and then you will divide it. So we write that number of cones in this case will be equal to volume of cylinder. See, volume of ice cream is basically equal to the volume of cylinder, is equal to, sorry, divided by volume of cone or ice cream cone, you can write. So let us come back to cylinder now. So what is the radius of the cylinder? Diameter is 12. So 12 by 2, that is 6 centimeter. And what is the height? This is 15 centimeter, right? So what is the formula for volume? Pi r square h. So 22 by 7, or don't put it, right? Because ultimately when you will divide, pi will get cancelled out. Put pi always in the end. So pi into r is 6 whole square and height is 15. So this will be centimeter whole square, one more centimeter, so centimeter cube. Leave it like this, okay? Now you come to this cone. Now again, what is the radius of this cone? That is 6 centimeter divided by 2, which is 3 centimeter. And height is 12 centimeter, right? Or give it some name. Let's say this, if I'm calling this a small h, so let me call it bigger h. Doesn't matter which, it's just a name. Call it small h or capital H, doesn't matter. So this one, let us say capital R. So volume is,
1 by 3 pi r square h.
yes, pi, now capital R square and capital H. Something different you have to name. So 1 upon 3 pi, leave it pi. Radius is 3 whole square into H is 12 centimeter cube, right? Now total 3 centimeter are there. Now let us divide it. So number of cones will be equal to, so as I write here, volume of cylinder, which is pi into 6 whole square into 15 centimeter cube, divided by 1 upon 3. So that means this 3 will come here, right? And only pi into 3 whole square into 12 centimeter cube. Is this understood? Right. So now, but there's a problem here. I'm finding the volume of ice cream cone, right? Basically, ice cream cone is also consisting of two parts. One is the volume of cone and plus the volume of the hemisphere, isn't it?
Yes, ma'am.
Yeah. So it's not complete. Right now, I cannot do it. So this is just the volume of cone. Now you find the volume of hemisphere. Hemisphere is how much? 2 by 3 pi r cube, right? Pi r cube. Radius will be same, which is of the cone. So you can write capital R cube. Is this clear? 2 by
Yes,
3 pi r cube. Okay. So this is 2 by 3, leave it pi. And r cube, again you can write 6 cube. Okay. So this is cone and this is your hemisphere, you can say. Now you add them. This will give you the volume of ice cream in one cone. Volume of ice cream in one cone. So this is equal to volume of cone plus volume of hemisphere. So volume of cone is how much? This is 1 upon 3 pi r square into 12. This is 1 upon 3 pi. Radius is how much here? 3 square into 12 plus volume of hemisphere is 2 by 3 pi 6 cube. Right?
yes, ma'am.
Okay. Now you can take first of all, you can write it like this: 1 upon 3 pi, and then this is 3 whole square into 12 and plus 2 by 3 pi. Now can I take out 1 6, right? And 6 square let me keep here. Is this clear?
Yes, ma'am.
Why? Because I just want to remove this denominator. So 3 into 1, 3 into 2. Similarly, 3 into 1, 3 into 4. So you can see pi into 3 square, which is 9 into 4 and plus 2 into 2, 4 into Then I have 1 pi. 6 square is 36. So I can take 4 pi common. 9 plus 36. So 4 pi into 9 and 6 is 15, 45. And that becomes 4 into 5, 20, carry to 180 pi. Clear? This is the volume of ice cream in one cone. Is this correct or there's some mistake here?
Ma'am, can you once go, ma'am?
Yeah, sure. Okay, just a rough work I'm doing, just 1 minute. 6 into 6 into 15 and then divided by 185 and the 60. Then 3. I'm getting my answer as 3. So there's one mistake here. Let us try to identify it. Please let me just help. Please help me out. First of all, what is happening in this question is that I have a cylinder which is full of ice cream, right? Now I am transferring the ice cream into cones. These are the dimensions of the cone, right? Okay. So ultimately, we have to find how many number of cones will be filled up. Fine, Harsha.
Yes.
So number of cones means basically I'm dividing the volume of the cylinder into some parts. So I take the volume of like one part and then divide the total volume. So I'll get the number of cones. Right, Hamna? Okay. Now volume of cylinder is this, that radius is 12 centimeter. 12 by 2 is 6. Height is 15. It is already given. Formula is pi r square h. So pi into 6 square into 15. This is right. Or if you want, you can just multiply. So 36 into 15 into pi. You can leave it like this. Clear?
Ma'am, for the hemisphere, you took the R as like instead of R, you took diameter.
Oh, that's the mistake. Yeah. So here, right? It was not 6, it is 3 cube, right?
Yes, ma'am.
Rest is all fine, I think. Fine, Harsha. Now come to this cone. Now cone is consisting of basically two parts. This much is your cone, right? And top of this is your ice cream. So the total volume of ice cream in cone is basically the volume of cone plus the volume of hemisphere. Understood?
Yes,
Right,
ma'am.
Harsha? Okay. So this is actually the total volume of ice cream, you can say. Total volume of ice cream in one cone. That is cone volume plus hemisphere volume. So I'm considering cone here. This is the radius, this is the height. So this much is the volume. Then I consider the hemisphere. I've done it here. Hemisphere. So 2 upon 3 pi. So this was the mistake. This was 3 cube. So instead of this 6 cube, it's actually 3 cube. This was the mistake. So 3 cube. Now this is simple. 1 upon 3 pi, or you can just reduce it, remove the decimal. Just a minute. 3 square into 12 and plus 2 by 3 pi. So 1 3 I'm just writing here, and then I'm keeping the other 2 in the square, right? So this 3 cancels out. 3 into 1, 3 into 4 cancels out. So I can take pi common, then I can take 3 square common. So here only 4 plus 2, right? So that is pi into 9 into 6. 6 into 9 is 54. So 54 pi I'm getting here. So now the number of cones is equal to volume of cylinder and divided by volume of ice cream in one cone. Now volume of cylinder I have just found here, 36 into 15 into pi. Centimeter cube. And this is the volume in one cone. Volume of ice cream in one cone. The pi get cancels out. This is also centimeter cube. This also cancels out. Now 6 into 6, 6 into 9. Okay. Now 3 into 3, 3 into 5. So 6 into 5 is, okay, 3 into 1, 3 into 2. And this is 10, simple. 10 number of cones can be filled up. Yeah, done. Next. Question number 6 now.
Ma'am, just 1 minute.
Okay.
Okay.
Right. Now, how many silver coins, 1.75 centimeter in diameter and of thickness, must be melted to form a cuboid of this dimensions? So you have a coin. Coin means it is like a cylinder with some height. If I just draw it a bit thicker, so it looks like this, right? So the diameter is 1.75 centimeter and thickness from here to here, thickness is 2 millimeter. Now be careful, there are different units, centimeter and millimeter, you have to convert it. Must be melted to form a cuboid. Okay, so how many coins you have to take if you want to form a cuboid of this dimension? So you have to form a cuboid whose dimensions, that means height is 3.5 centimeter, length is 5.5 centimeter, and breadth is 10 centimeter. So this is the same question. So number of coins means here that you have to divide the complete volume by the volume of one coin, right? So volume of cuboid and divided by volume of one cone. That's it. So separately, let us find out. So if I talk of cuboid, first of all, these are the length I mean, these three are given. So volume of cuboid is simply length into breadth into height. Length is 5.5 centimeter, 10 centimeter, 3.5 centimeter. Right? So at least 110 can cancel out. It will become only 55 and into 3.5. Is that okay? Centimeter cube. I mean, you remove the decimal of 55, 10 will come in the denominator. Then this 10 cancels out. So only 55 into 3.5. This you can again write 55 into 35 by 10 and centimeter cube, right? Can you multiply 55 into 35 quickly? Or you can leave it here, okay? Because ultimately we have to divide, then hopefully something will get cancelled out. So I can leave it like this, right? Now you come to coin. Come to coin. So coin is, or I can write cylinder. Coin is basically my cylinder whose radius, let us call it capital R, or okay, R. This will be 1.75 divided by 2 centimeter. Clear? And height, h, this is 2 millimeter. Now I told you milli, centi, deci, meter, deca, hecta, kilo. So you're going from millimeter to centimeter. That means towards a bigger unit. So you have to divide by 10. Understood? So if you divide this by 10, now it will become centimeter. Is this clear, all of you?
Yes.
Okay. Now volume, what is the formula? This is pi r square h, right? So pi, leave it pi. But here I can't leave it pi because I don't have pi in here, okay? This is cuboid. So pi will not be cancelled out. Put the value of pi, 24 by 7. Radius is this 1.75 divided by 2 whole square. Height is this 2 by 10. And then this is centimeter square, centimeter cube. Is this understood?
Yes, ma'am.
Okay, so I can simplify this a little bit. This will be 22 by 7. Then I can remove the decimal. So 175 by 200, right? And then again 175 by 100. No, it will become 4. This is also in square. 2 square is 4 in the denominator. And into 2 by 10 centimeter cube. So you can cancel out a little bit. So 7 into 1. 7 into 2 is 14, 35. So 7 into 5 is 125. Then here you can do that 5 into 5
Why have we written 175 twice?
because this is square, right? Pi r square h.
Okay, ma'am.
And then denominator 2. So 2 square will become 4, right? And then I'm removing the decimal. So it will become 400. Is that okay?
Then why about 175 by 100?
You can write 4 into 100. That is also
The next term.
Yeah, so this 400 is from removing this decimal, and this 100 is from removing the next decimal.
So
But
that would have 400.
okay, let me do it here again. See here, volume is pi r square h, right? So this is 22 by 7 into radius is how much? 1.75 divided by 2 whole square. Clear? Into height. What was the height? 2 by 10. Okay. So 2 by 10, right? So this is 22 by 7 into now 1.75 by 2 into 1.75 by 2 into 2 by 10. Is this clear now?
Yes.
Okay. Now remove the decimal from both into. So this becomes 1.75 divided, sorry, not 1 point now. Simply 175 divided by 2 into 100. So whether you write 2 into 100 or 200 means the same thing. And this is again 175 divided by 2 into 100. 2 into 10, right?
Yes.
Okay, now this 2 cancels out. Okay, this you can reduce. And here also 7 into 1, 7 into 2 is 14, and then 35, 25. Now don't disturb the denominator. Just multiply 25 into 175. Now this by 11. So I'm getting this 48125 divided by 100 into 100 into 10. So 5 zeros. So 0.48125, right? And of course, this is in centimeter cube, right? Centimeter cube. This is the volume of one coin I have got. Now, number of coins will be, that means volume of cuboid divided by volume of one coin. Now, volume of cuboid, how much did we found out? Okay, I left it like this. 55 into 35 divided by 10. So 55 into 35 and then divided by 10, right? So you can do one thing like don't put the decimal value here, put this thing. So into 48125 and then 123450. This is clear because ultimately again you have to remove the decimal, right?
Yes.
Okay. Now with the table of 5, you can reduce it a little bit. So at 1 0 will cancel out from here. And again, before multiplying, do one thing. See, ultimately, I'm not interested in this answer. Got it, Hamna? The answer is actually this I want to find out. So don't multiply and make it such a large number. You can leave it like this into small numbers. So now I have 11 into 25 into 175 and then divided by 100 into 100 into 10. Is this okay? Right? Why? Now you will see why. So instead of writing like such a large number, I'm not writing it like this. So I'll write 55 into 35 divided by 10, which is the volume of cuboid, and into volume of one coin. So right here 11 into 25 into 175, right? And the denominator will come here 100 into 100 into 10. Now don't you think it will be easier to solve?
Yes,
Yeah,
ma'am.
yeah. So now again reduce some numbers here. So 1 0 cancels out, 10 actually goes out. Now 11 into 1, 11 into 5, 5 into 1, 5 into 5, right? Then 5 into 1, 5 into 7. Again 7 into 1, 7 into 2 is 14, and then again 35, so 5. Okay. Now I think everything is gone. So at least 100 you can reduce. So 25 into 1 and 25 into 4. So ultimately 4 into 100, and the answer is 400. So that is why I ask you, like, don't solve in between, just leave it like this. Do the final calculations in the last step. Put here centimeter cube. Yes, Hamna, is this understood?
Yes, ma'am.
Okay. Now question number 7. Written, Harsha?
Yes, ma'am.
Okay. 7th. A cylindrical bucket of some height and radius is filled with sand. Okay. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is, find the radius and slant height. This is a simple question, right? You have a cylindrical bucket which is full of sand. Sorry, it looks like this. So everything is given, like the radius of this bucket is given. Radius of base is 18 centimeter. Height is 32 centimeter. Right. Now this bucket is emptied and a heap of sand is formed, which is of course a conical shaped, right? Heap looks like this on the ground. So it's a cone whose height and is given, I think. Yeah. If I call it a small h, which is 24 centimeter. I want to find its radius and slant height. So if I'm calling this radius as a small r and the slant height by L, so I can call this as capital R and this height as capital H. No issue. Just because they are different figures. So in this case, the volume of the cylinder is equal to the volume of the cone. Yes.
Yes, ma'am.
Yeah, because it was filled with sand. So here, volume of cylinder or cylindrical bucket is equal to volume of conical heap. So one by one, let us find out the volume. And let us come to cylinder now. So height is 32 centimeter. Radius is 18 centimeter. Volume becomes pi r square h. Don't put pi into r is 18 whole square, h is 32, sorry, only 32, and this becomes centimeter cube. Okay, leave it like this. Now come to cone. Okay, so first of all, you have to find a radius. Once you find the radius, then only you will be able to find L, because L is, as you know, square root of h square plus r square, right? So let us find out r first of all. Okay, that's your equation number 1. Now cone is, height is 24 centimeter. Radius you don't know, so the volume becomes 1 upon 3 pi r square h. This is the formula, right? So 1 upon 3 pi r we don't know, only h we know, that is 24 centimeter. Clear? So now these two are equal, so put them in equation number 1. So from 1, pi into 18 whole square into 32 centimeter cube is equal to 1 upon 3 pi r square into 24 centimeter. Clear? Now pi cancels out, and now cross multiply. So 18 into 18 into 3 into 32 divided by 24, and only centimeter square will remain. This is equal to r square. This is clear, right? Now you can reduce it a little bit. So 3 into 1, 3 into 8. Sorry, 8 into 1, 8 into 4. That's it. Yeah, simple. Don't disturb it now. See, 18 into 18 and 4 you can again break 2 into 2, right? And centimeter square. This is equal to r square. Now you take square root, so only 118 will come, only 1 2 will come, and like 1 centimeter will come. That becomes your r. Clear? And 18 into 2 is how much? 36 centimeter is your r. Yes. Now you have got r, you can find slant height L. So if I find it here itself, so square root of h was 24 whole square, r is my 36 whole square, and of course this is in centimeters, so, and I'll take centimeter common, I'll bring it out of the square root, so this will be centimeter only. How much is 24 into 24? This is 576 plus 1296. Now you add it. This is square root of 1872 centimeters. So you can prime factorize it. Getting this. Is this correct? Let me do the prime factorization again. You also try, please.
We can do with 3, right?
3. Oh, yes, it is divisible by 3. Why I'm not seeing that? Yeah. So 3 into 3 is 9. 27. So 3 into 9. Oh, yeah. 3 into 1. Yeah, okay. And 13 will come here. Yeah, because there was a 13, so ultimately it had to come. All right. So there are pairs. Okay, so your L will become 2 into 2 into 3, and then like 1 under root 13 will remain, right? Because there is no pair, it will remain in under root. 2 into 2, 4 into 3, 12. So 12 under root 13 is your slant height. Next now, water in a canal 6-meter wide and 1.5 meter deep is flowing with the speed of this, okay? How much area will it irrigate in 30 minutes if 88 centimeter of standing water is needed? Right. So canal actually looks like this. So, flowing body of water, and which is having some high depth also, right? Let's say this is the depth of the canal. Understood, Amna? And the water is actually, flowing like this, right? So it's basically in the shape of the like if I cut the canal like this, so at least this face looks like a cuboid, isn't it?
Yes, ma'am.
Okay. So some dimensions are given 6-meter wide. So this is 6-meter. This side is 6-meter. 1.5 meter deep. 1.5 meter is basically the height of this cuboid, and is flowing with the speed of this. So the speed of water which is flowing here is I can say 10 kilometer per hour. So you can write that cross section of canal. Cross section, you understood? If I cut something, so the face which is visible to you is called the cross section, right?
Yes, ma'am.
Okay. Yes, Hamna, cross section, do you understand?
Yes, ma'am.
Okay. So cross section is this face of the canal, which I can see, which is in the shape of a cuboid. So cross section of canal is in the shape of cuboid, right? So whose you can say 2 dimensions are given, because this side you don't know, like this length you don't know, only let me call it breadth. So breadth is 6-meter and height 2 are given, so 1.5 meter are given. Speed is given. So from this information, speed, we will actually find out the length. Now, what is actually speed? You know this formula is speed is distance upon time,
Yes, ma'am.
right? Okay. So that means speed into time will give you distance, right, Hamna? Okay. So if I take this time as 1 hour, right? So if that means speed into 1 hour, or no, just a minute. So this is fine. Speed into time is actually distance. Is this okay? Or if you look at this formula, can I just write it like this? That speed is equal to 10 kilometer, and this hour can I write here? No, no problem.
Yes.
And if I just cross multiply, just try to understand this thing. So speed into hour means there's nothing, that means 1 hour. Clear? So speed into 1 hour is actually 10 kilometer. Is this understood, Hamna?
Yes, ma'am.
Yeah. So from here I can say that length of canal in 1 hour is 10 kilometer. That means the water which is flowing at a speed of 10 kilometer per hour. So in 1 hour, it is covering a length of 10 kilometer. Is this understood? Because canal is very long. So somewhere we have to take a certain length, that from here to here we are taking it, because it's a flowing body of water. So this much length I'm taking uh, for 1 hour. Like if the water flows for 1 hour, the water starts at a point, let's say, right? It is flowing from 1 hour, and after 1 hour the water, let's say, it reach here. So basically this length I'm interested. Is this understood? Right? For example, there's a certain water is made up of molecules, right? Just think of it like this. I am just fixing one molecule, so I'm just pointing out this molecule of water. This is flowing, flowing, flowing from 1 hour, and it reaches here after 1 hour. So I see that how much distance the molecule of water has covered. Understood? So in 1 hour, this distance which is covered by this particular molecule of water will be 10 kilometer. I hope this problem is clear.
Yes, ma'am.
Yes. Okay. So from here, basically, I have written this line. Now let us convert hour into minutes. So I can say that length of canal in 1 hour means 60 minutes. So in 60 minutes, it's 10 kilometer. That's it. So if I want to calculate the length of canal in 1 minute, what will it become? I'll bring this 60 here. So it will become 10 upon 60 kilometer. Is this clear? This 60 will
Yes.
come in denominator. Okay. Now in the question, it is asking how much area will it irrigate in 30 minutes. So I want the length in 30 minutes. So for 30 minutes, what will I do? If I just write the line here, so that means length of canal in 30 minutes will be 10 upon 60 and multiply by 30 kilometer. This is clear. This is simple unitary method. Understood, Hamna? See, this is continuation. I don't have space here. So I'm just writing the next line here, right? You can just solve it. 3 into 1, 3 into 2, and then 5 kilometer, right? And if you further break it, it will become 5 into 1000 meter. So in 30 minutes, the length of the canal in 30 minutes is 5000 meter. Is this clear so far?
Yes, ma'am.
Okay, so let us find. So I have got the length also, the missing dimension which was not there. Now I can find the volume of water. Understood? Okay, next page I'm going now. So volume of canal, that is now length into breadth into height. Length I have found 5000 meter because breadth and height was in meters, so I had to convert it. Breadth was 6 meter and height was 1.5 meter. It's given in the question. So if you remove the decimal, so 10 will be gone. So 500 into 6 into 15 and meter cube. Okay. Leave it like this if you wish. Now what else in the question? How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? Okay, so now what will you do? So basically, now understand it like this. Let's say this is the volume of canal now. Fine, Hamna.
Yes, ma'am.
Okay, let's say this is how your canal is looking. This much portion we have taken, and this is the volume of this canal. Now, this canal is actually irrigating a land, right? Basically, this water is going into some land. So, how much area it is going to irrigate? So, can I say that volume of water in canal will be equal to volume of area irrigated? See, area is because two-dimensional. I am equating, so three-dimensional will be equated with three dimension. Fine, Amna?
Yes,
Harsha. So both the volumes will be equal. So let's say this is the land whose area is this. The base is the area, and if you multiply the height, so that becomes the volume of the area irrigated. Harsha, is this clear?
Yes,
because
ma'am.
because the water is standing in that area. Sometimes water is keeps on standing, so if you place your foot, let's say up to your knees or up to your calves, the water is coming. So basically this area of land is actually filled with water up to some height. So the amount of water which is staying in this area is equal to the volume of the canal. I hope this is clear in your mind. Yes. Let us just write it properly. Yes, Hamna, is the problem clear in your mind now?
yes, ma'am.
Okay, if you're confused, you can ask this. So now it is given that volume of water in canal is equal to volume of area irrigated. Understood? Okay. So volume, I can break area into height. Clear? So area, I don't know, because they are asking in the question that how much area does it integrate, and height is given in the question that 8 centimeter of water is standing. Clear? So I can write it. This I have calculated, which is 500 into 6 into 15 meter cube, right? Is equal to area. This is area irrigated, right? Right, complete. This is equal to area irrigated into height of water, which is standing. Height of water, which is standing, is 8 centimeter. Convert it in meter, it becomes 8 upon 100 meter, right? Now, can you find the area irrigated from here if I leave it for you? So take everything here, 500 into 6 into 15 and into 100, right? And then you have meter cube divided by 8 will come here and 1 meter will come. So ultimately you will get area irrigated. And that you can see 1 meter cancels out and the answer will be in meter square, which you should get because you are finding area. So just simplify a little bit here. What can you do? 2 into 3 and 2 into 4, right? Now 4 into 1. 4 into 1 is 4, then 10. So 4 into 2 is 8, then 20. So 25, right? Now quickly multiply. 125 into 3. 3 into 5 is 15. Carry 1. 6 and 1, 7. 375 into 15. I'm getting this 5625, then 2 zeros, meter square as my area irrigated. Yeah, can you tell me in which unit the answer is given at the back of NCERT, Hamna? Meters or something else?
Ma'am, meter square and hectares as well.
So meter square, is this correct? 562600?
Yes, ma'am.
2500, okay. So you can convert it in hectare. So just note it down. Actually, 10,000, 40. So 10,000 meter square is 1 hectare. Got it? And then you have this much meter square. So that means 1 meter square is 1 hectare divided by 1000, 4 zeros, right? So that means 562500. Now in place of this meter square, you can write 1 upon answer now will be in hectare. Is this understood?
Yes, ma'am.
Is equal to area irrigated. So 2 zeros you can see you have cut from here. So ultimately you have 5625 and divided by 100 hectare as your area, and that becomes 56.25 hectare. Fine, Harsha?
Yes, ma'am.
Okay. So how many questions remaining now?
Ma'am, one.
Okay, that we will complete in the next class. Okay, now you can leave.
Thank you, ma'am.
Okay, bye. Okay, Jaslyn, let's wait for 1 or 2 minutes. Then I'll start.